Alfred Lothar Wegener was born November 1st, 1880. Then, in 1904, he received a PhD from the University of Berlin. Other interests of his included geophysics, meteorology, and climatology. He came up with the first weather balloon, as well as a textbook that became the standard in Germany. He then served in the military, got wounded as a soldier, and ended up forecasting the weather for the military towards the end of the war. Then, in 1924, he accepted a professorship at a university in Austria, physics and meteorology. In 1930, Wegener went up with 14 men back up to the Greenland ice sheet. Went up a couple times before. This time they wanted to set up some permanent bases so they could measure the ice sheet year-round. Success for the expedition depended on supplies being delivered from the west camp to the mid-ice camp for 2 men to winter there. However, due to a late thaw, the expedition was 6 weeks behind schedule, and so the men didn't have enough fuel, so they said they'd return on October 20th. Wegener and Rasmussen headed out. They didn't take any food for the dogs. They figured they'd just kill the dogs one by one and feed the rest of the animals and themselves as well. As they were going, once they got down to one sled, Wegener was on skis and Rasmussen was on the sled. Because of overexertion, Wegener ended up dying because of heart failure. Years old at this point in time. So we lost a great scientist, but it was all in the aspect of where he was trying to help other people. Back in 1911, Wegener came across this paper at a university. You had the same plants, animals, and fossils on both continents of Africa and South America particularly. However, they were separated by the Atlantic. The prevailing theory at the time was that there's this massive land bridge that allowed this to happen. However, Wegener also noticed that South America and Africa fit together quite nicely. This was the beginning of continental drift, or plate tectonics. Pictured here is the continent of Pangaea. This is where all the land masses were together at one point, and then from this point forward they split apart into where they are today. Posted here are the evidences. First of these is magnetism or paleomagnetism, which is very useful in igneous flows or lava flows. Corresponding rock strata, so that just means where you've got this set of strata is the exact same as the strata over here. That is what we call index fossils, because you've got the same fossils in the same beds at the same time. The other one is direct measurement of plate movement, which has to do with with satellites, seismic activity, earthquake foci, and the fit of continental coasts. Now we're not going to go through all of these, but we will touch on a number of them. Here we have the rock strata, or layers. As you can see, you've got glacial till, coal, shale, sandstone, basalt lava flows. And between the sandstone and the glacial, you had this fossil that was found within there. So it had a short lifespan, widely distributed, very good key indicator. And these layers of rock were formed in Antarctica, Australia, South America, Africa, and India before Pangaea broke apart. So this kind of tells us the age as well as the time frame, giving us more evidence for plate tectonics. As we were talking about fossil evidence before, this is a perfect map that shows where different fossils were found and how they're able to correlate the different eras. So just another evidence about plate tectonics. In this last section, we're going to go more over these big plates move. Now, pictured you have the South American plate and the African plate with the mid-Atlantic in the middle. And as you can see, you have the heated material that expands and rises. And as this is happening, you also have these convection currents where the hot magma rises, moves along the along the plate, cooling down, sinks, heats back up, and it keeps going, pushing the plates apart or push them together depending on what's going on. And that is an overview of plate tectonics and continental drift.